Alright, welcome to this discussion on ballistics. So, ballistic evidence can help determine what kind of firearm was used, the caliber of the bullet, number of bullets fired, where the shooter was, where the victim was, how recently the weapon had been fired, and if the firearm had been used in previous crimes. So a little bit of history here for you. The gunpowder has been invented over 1,000 years ago by the Chinese, and here's some very early guns. They actually had wicks to ignite the gunpowder. Okay. And there are several distinctions of firearms. We'll look at these different categories here. So long guns would include rifles as well as shotguns. A shotgun fires pellets in the form of a shot or single projectile called a slug. A handgun, which is designed not for two hands but for just one hand, includes a pistol, which you see here, and a revolver, which has a usually a 6 cartridge holder that the cartridges go in here. They're loaded into the revolving mechanism. And then there are also automatic and semi-automatic weapons. If you look down the barrel of a gun, and were to be able to cut it into cross-section, you would see lands, which are parts of that metal of the barrel which protrude, and then grooves, which are indentations in the metal of the barrel. And it's the lands and grooves that cause the bullet to twist. Now think about a quarterback throwing a long pass, and imagine him trying to do that without putting any kind of spin on the ball. It would be very hard to make it go as far and as accurately. And the same is true with a firearm. So the lands and grooves can be oriented in different ways, and the way that they're oriented will affect the marking that's put on the bullet. And those markings are very important for forensic investigation. If the lands and grooves are oriented in such a way that it causes the striations to be going like toward the right hand curve here, that's called a right twist. And then a left twist is when you look at the bullet and you see the striations going to the left. So let's look at the parts of a cartridge. Now first of all, we come from varying backgrounds of experience with firearms. So you may look at this and think, oh, this is a bullet. But in actuality, the bullet is just the part that goes through the barrel as the projectile. Altogether, this is known as the cartridge. And the individual components include the bullet, which sits out front, the bullet case, which is this metal jacket, gunpowder, which resides toward the back here, and then the primer in the rim of the cartridge. And this is where the firing pin is going to initiate the spark, which will then light the gunpowder and cause the bullet to move into the barrel. So this is a closer look at that process. When the trigger is pulled, step 1, then the firing pin, which has been cocked back, then quickly releases. The firing pin hits the primer in the rim of the bullet, and then that causes a spark in the primer, and this is going to then cause, because of the pressure, an explosion, which is going to push the bullet from the cartridge into the barrel. And then the bullet follows the lands and grooves that we talked about, spiraling out of the barrel. Now caliber is a word that we use to describe the diameter of the cartridge, which is measured down here. So this is measured in hundredths of an inch. Sometimes you'll find it in millimeters depending on the type. And then so common calibers would be a 22 caliber, 25, 44, 45. So the larger the number, you can assume the larger the cartridge. And of course it's important for the ammunition to match in terms of the caliber of the ammunition to the correct caliber of the firearm. So one thing that can be evaluated in ballistics evidence is the use of a comparison microscope specifically, which allows you to have two different objects focused in two different lenses in the microscope you can see one bullet, let's say, in the left eye, one bullet in the right, and you can compare those two different bullets. Now, what are you looking for? You're looking for matching lands and grooves, and this can perhaps tell you that the bullet was fired by the same firearm, or maybe not, maybe by a different firearm than the firearm that suspect 3 is known to own. In order to make this comparison, let's say that there's a bullet that's been recovered from the victim's body, and there's a suspect who has a firearm that needs to be tested for a match to the bullet in the victim. Well, you wouldn't want to just take the firearm, shoot it into the grass, and go try to find the bullet and then compare it, because anything that it hit in that firing could arguably affect the striations. So what is done is a bullet firing tank or a water tank is used, where a test fire can be done by firing the firearm into water, which is very dense and does a great job at slowing down the bullet, especially because it's at an angle, so the surface area of the bullet is greater in terms of its contact with the water, slows it down. And so those two things can be compared. 4 to 6 commonalities between bullet A and bullet B in terms of the exact striations are looked for. And this doesn't just vary with, like, let's say a certain model of a firearm always produces like bullets. No, it's an individual type of evidence. So there are differences in the way that a gun is cleaned, or the way that in the firing of it, that it will form slight impressions and indentations that cause unique evidences to be put on that bullet, so it goes straight to that particular firearm. Some of the marks are not on the bullets, but on the spent cartridge casings. This includes firing pin marks, which you see here. So when the firing pin hits the primer, it leaves a particular impression. Also the breech block marks when it casing slams backward into the back part of the gun. Extractor and ejector marks when the casing may be released. Now, gunshot residue is a residue that forms with the unburned powder and also the traces of smoke when a firearm is shot. And this can accumulate on the hands and clothing of someone who's fired it. However, it can also accumulate on somebody who is just standing there. So for that reason, gunshot residue can be helpful, but not a deciding factor in a case when there's no other corroborating physical evidence. Okay, let's look at trajectory. So this is going to bring in some physics here for us to understand how we can calculate things like the height of the shooter. Let's say that we've got a couple of reference points. We need at least 2. Let's say the glass of the bullet fired through, and then perhaps the victim's head, or if there was nobody sitting here, perhaps the cushion in the seat where the bullet landed. So the idea is, if we have 2 reference points, then we can use a process called triangulation to try to figure out something like the height of the shooter. So those reference points, as we said, can be bullet holes in objects, entry point and exit point of a victim, and possibly gunshot residue or spent cartridge cases. Lasers can help to trace the path as well. So just a bit about trajectory. This is very exaggerated, but a bullet's path does curve due to gravity. When we do triangulation and we're evaluating trajectory, we're going to make an assumption or an estimation that the bullet is traveling in a perfectly straight line, as a triangle line would be. So that's one of the possible areas of error, because it is estimated, because gravity is not accounted for there. So with that being said, let's look at this problem. We know that there's a building where a shooter was located, and the building is 60 feet away from the car. We know that the bullet hole through the window is 4 feet above the ground, and we want to know where was the shooter at the time of this shooting. So what we can do is we can say, okay, here's the car window. I know the distance from here to here, and I know the distance from here to here. And because of the properties of a triangle, the distance from big A little b is the proportional to big A little c, as big A big B is to big A big C. So we're just making a ratio. So we're saying this length to this length is equal to this length to this length. And so what you get is that AB, this line here, is equal to 732.3 inches. Okay, well, how does that help me? Well, we need to use the Pythagorean theorem, and that's where we use the 90-degree angle right here. And we say, okay, this is my hypotenuse. Therefore, AB squared, which I know the value, is equal to AC squared plus BC squared. And ultimately, this is what I want to know. So when I solve that through taking the square root, I find out that BC is 11.1 feet. And that can even tell me which floor, perhaps which window the shooter was at when he fired that shot. Now remember that the bullet hole was an initial 4 feet off the ground. So we're going to take our 11.1 feet, add 4 feet to it, and we're going to get the total height of the shooter. Now in class we'll also work this problem using a different means, using some trig. So I want you to be able to use both, but I wanted to go ahead and show you the triangulation. Alright, let me ask you a few questions, and I'd like for you to, in your mind, go ahead and formulate an answer to each of these. Okay, so think through these, and I'd like you to go ahead and pause your video now. Okay, so let's talk through the answers to these and see how it compares with what you were thinking. The first question, exit wounds are larger than entrance wounds because the skin is somewhat elastic, it stretches as the bullet enters, but the exit wound has to be larger as the bullet moves through the body, collecting body tissue and bone with it. Now, fibers embedded in the wounds can indicate direction of penetration. Gunshot residue found on entrance wounds, so that can also help for directionality. When a gun is fired with the muzzle touching the victim's skin, the hot gases released can leave a mark called a stellate, or a star-like pattern with the breakage of the skin. And lastly, high-speed bullets are more likely to pass through body than low-speed. Okay, that's easy to understand. Therefore, small caliber bullets tend to lodge within the body because they tend to be shot at a lower velocity, while larger caliber bullets, because they would often have more gunpowder, stronger firearm, they're going to be traveling faster, tend to pass through. Alright, well, I'd like to say thanks for joining in for this talk about ballistics.